Welcome, everyone. I am so glad you're here for today's explainer because, well, we're about to embark on a truly epic voyage. We're going to take a step-by-step journey right through our cosmic neighborhood. We'll be traveling outward from the sun, exploring the 8 major planets, checking out their extreme environments, and then heading out to the fascinating dwarf planets at the very edges of what we know. So, get comfortable. Let's prepare for liftoff on a scientifically grounded flight through our solar system. To really understand our place in the universe, we actually need to zoom all the way out first. That massive, swirling structure, that is our galaxy, the Milky Way. And it is incredibly easy to feel totally lost in the sheer scale of the whole thing. But right there, in that bright pinpoint of light, that represents our solar system. That's exactly where we live. Starting with this giant macro perspective kind of helps us appreciate just how special our little pocket of the universe actually is. Okay, let's zoom right back into that bright light and see what exactly makes up our home. Okay, let's dive into this. Here is our flight itinerary for today. First, welcome to the solar system. Next up, the inner planets. Then we'll fly past the giant planets, cool down with the ice giants, and finally, push out to dwarf planets and beyond. Part 1. Welcome to the solar system, our cosmic anchor. And here is the anchor itself, the sun. Our sun is a star, sitting dead center in our solar system, and it is absolutely the main vital source of light for everything around it. We've got 8 major planets here, and the sun's incredible gravitational pull is what keeps every single one of those 8 worlds locked in a continuous revolving orbit. Literally, without the sun, there is no solar system. It's the brilliant engine driving the entire mechanics of our neighborhood. Part 2, the inner planets, our closest neighbors. We're starting with Mercury, the absolute closest planet to the sun, 88R. That represents the sheer blistering speed of this planet's orbit. A single year on Mercury is only 88 Earth days long. And as a really fascinating side note, despite being tucked so incredibly close to the sun, this tiny little speedster was actually visible from Earth back in 2016. It's just a great reminder that our planetary neighborhood is constantly dynamic and moving. And this brilliantly illustrates the extreme contrast between the second and third planets from the sun. Venus is actually the hottest planet in the entire solar system, and that's because its atmosphere contains a massive amount of carbon dioxide, which violently traps heat kind of like a cosmic greenhouse. Now compare that to our favorite planet, Earth. Earth is entirely unique. We have a suitable climate, incredibly diverse natural landforms, and vital water bodies that support life in all its forms. Plus, it's accompanied by our single natural satellite, the Moon. The difference in the environment between these 2 neighboring planets is just absolutely staggering. Wrapping up the inner planets, we have Mars, famously known as the red planet because of its very distinct reddish appearance. But Mars isn't just known for its color, it's really defined by its extreme weather systems. See, Mars is home to some of the absolute largest dust storms in the solar system. And we aren't just talking about local afternoon weather events here. These massive storms can continue for months at a time and physically blanket the entire world. It's a chaotic, dusty place, and it perfectly concludes our tour of the rocky inner planets. Part 3. The giant planets. These are truly massive worlds. Behold Jupiter. Jupiter absolutely reigns supreme as the largest planet in our entire solar system. Honestly, the sheer volume and scale of this gas giant are difficult to even overstate. It's also accompanied by 4 major moons. But, it's not just Jupiter's size that makes it an extreme planet. It's actually the speed at which this giant operates. 9 hours and 55 minutes. That is the length of one single day on Jupiter. Despite being the largest, most massive planet we have, it completes a full rotation faster than any other planet in the solar system. The absolute shortest day of all the planets. Just imagine the dizzying rotational forces at play to spin a planet of that immense size in under 10 hours. It's wild. Now, what's really interesting about this is the number 150. Because as we fly outward to Saturn, we aren't just looking at a planet anymore. We're essentially looking at an entire miniature solar system. Saturn is surrounded by about 150 frozen moons. When you contrast that with Earth's single moon, it really gives you a sense of the incredible gravitational dominance of these giant planets. And among this massive collection of frozen satellites, the largest one holds the impressive title of Titan. Of course, you literally cannot talk about Saturn without pausing to admire its most iconic feature. Saturn is encircled by those beautiful, sprawling rings. But they aren't solid tracks like a racetrack. These massive structures are composed entirely of countless individual pieces of dust and ice, all trapped in orbit. It's this delicate, freezing, and incredibly beautiful dance of debris that crowns the realm of the giant planets.
Part 4. The Ice Giants. This is where we hit freezing extremes.
Negative 224 degrees Celsius, this totally staggering number belongs to Uranus. Sitting this far out in the solar system means the energy from the sun is incredibly faint by the time it reaches here, leading to brutal, freezing extremes. It is an environment completely alien to anything we would ever experience here on Earth. And just think about how vast the orbits are out here in the deep freeze. It takes Uranus 84 Earth years just to revolve around the sun one time. And it takes Neptune a massive 165 Earth years to complete a single orbit. Neptune is officially known as the ice giant, and it boasts a collection of about 14 moons in its distant dark orbit. The scale of time and distance out here is truly hard to wrap your head around. Let's move to Uranus's seasons and see how this builds on that 84-year orbit we just talked about. Because of exactly how Uranus rotates as it makes that super long journey, it experiences seasons unlike anything else. Out of that 84-year orbit, the planet gets direct sunlight for 42 years. And the rest? 42 years of total unbroken darkness. Literally imagine a winter night that lasts for over 4 decades. It is hands down one of the most bizarre and extreme environmental realities in our entire solar system. Part 5. Dwarf planets and beyond. So, while the major planets definitely get most of the spotlight, it's absolutely essential that we register the rest of our solar family. We actually have 5 recognized dwarf planets: Ceres, Pluto, Eris, Makemake, and Haumea. These 5 distinct bodies are a crucial part of our cosmic neighborhood. They hold their very own unique orbits and histories right out there at the fringes of our system. So the crucial point is that while we always think of Earth as the ultimate water world, the blue marble, the wider solar system is actually full of hidden extremes. For instance, Ganymede, which is one of the moons orbiting Jupiter that we passed a little earlier, actually contains more water than the Earth. Let that sink in for a second. A moon, out in the freezing cold depths of space, holds more water than all of the mighty oceans on our entire planet combined. Unbelievable, right? Which brings us to the end of today's visual journey and really leaves us with a pretty provocative thought. If a single moon like Ganymede can hold more water than Earth, what other incredible secrets might be hiding on the hundreds of other moons orbiting our planetary neighbors? From Titan all the way out to the 14 moons of Neptune, there is just so much we have yet to uncover. I really hope this explainer gave you a fantastic look at the sheer scale and wonder of our solar system. Thanks so much for joining me, and I will see you in the next one.